The history of synthesizers dates back to the early 20th century when electronic instruments started to emerge. One of the earliest electronic instruments, the telharmonium, was invented by Thaddeus Cahill in 1897. It used rotating tone wheels to generate musical sounds and can be considered a precursor to modern synthesizers. However, it was large and cumbersome, limiting its practicality. The first true synthesizer, the RCA Mark II sound synthesizer, was developed in the late 1950s by Herbert Ballar and Harry Olson at RCA Laboratories. It was a room-sized machine that used vacuum tubes and analog circuits to generate and manipulate sounds. This marked the beginning of a new era in music production technology. In the 1960s, Robert Moog revolutionized the synthesizer industry with the introduction of the Moog synthesizer. It was the first commercially available synthesizer that used voltage-controlled oscillators, filters, and amplifiers. The Moog synthesizer gained popularity among musicians and became a staple in electronic music production. Throughout the 1970s and 1980s, synthesizers continued to evolve with the introduction of digital synthesizers such as the Yamaha DX7 and the Roland D50. These synthesizers use digital signal processing to create a wide range of sounds and effects, expanding the possibilities for music production. In the 1990s, software synthesizers started to gain popularity with the development of virtual instruments that could be run on computers. This allowed musicians to access a wide variety of sounds and effects without the need for physical hardware. Today, synthesizers come in various forms, from hardware synthesizers with tactile controls to software plugins that can be used within digital audio workstations. They are used in a wide range of musical genres, from electronic dance music to film scoring. The history of synthesizers is a testament to human creativity and innovation in the field of music technology. As technology continues to advance, we can expect even more exciting developments in the world of synthesizers and music production. There are several types of synthesizers that have been developed over the years, each with its own unique characteristics and capabilities. Analog synthesizers, such as the Moog Model D, use analog circuits to generate and manipulate sound waves. They are known for their warm and rich tones, making them popular among musicians seeking a classic sound. Digital synthesizers, on the other hand, use digital signal processing to create and modify sounds. They offer a wide range of sonic possibilities and can emulate a variety of instruments and effects. Hybrid synthesizers combine both analog and digital components to take advantage of the strengths of each technology. They offer the best of both worlds, allowing for flexibility and versatility in sound design. Modular synthesizers consist of individual modules that can be connected and patched together to create custom signal paths. They offer a high level of control and customization, making them popular among experimental musicians and sound designers. Virtual synthesizers, also known as software synthesizers, run on computers and can emulate the functionality of hardware synthesizers. They are convenient and cost-effective, allowing musicians to access a wide range of sounds without the need for physical hardware. Each type of synthesizer has its own unique characteristics and advantages, catering to different preferences and needs in music production. The evolution of music production technology has been a fascinating journey marked by significant advancements and innovations that have revolutionized the way music is created and produced. The early days of music recording were dominated by analog technologies, such as magnetic tape recorders and vinyl records. These technologies laid the foundation for modern music production and set the stage for future developments. In the late 1940s, the introduction of the magnetic tape recorder by German engineer Fritz Flömer revolutionized the recording industry. This technology allowed for multi-track recording, editing, and overdubbing, giving musicians greater flexibility and control over their recordings. The 1960s saw the rise of the transistor and integrated circuits, leading to the development of smaller and more portable recording devices. This era also saw the emergence of the first commercially available synthesizers, such as the Moog synthesizer, which paved the way for electronic music production. The 1970s and 1980s witnessed the advent of digital recording technologies, such as digital audio workstations, DAWs, and MIDI, musical instrument digital interface. These technologies allowed for precise editing, sequencing, and manipulation of musical data, revolutionizing the way music was produced. The introduction of sampling technology in the 1980s further expanded the creative possibilities for musicians, enabling them to incorporate pre-recorded sounds into their compositions. The 1990s brought about the democratization of music production, with the rise of affordable home recording equipment and software. This empowered musicians to create professional quality recordings from the comfort of their own homes. The 21st century has seen a rapid acceleration in music production technology, with advancements in artificial intelligence, machine learning, and algorithmic composition. These technologies have opened up new avenues for creativity and experimentation in music production, allowing for the creation of music that was previously unimaginable. As we look to the future, we can expect even more exciting developments in music production technology, pushing the boundaries of what is possible in the world of music creation. Algorithmic composition is a fascinating approach to music creation that involves the use of algorithms and computer programs to generate musical material. By leveraging mathematical formulas, rules, and processes, composers and musicians can explore new sonic landscapes and push the boundaries of traditional music composition. One of the earliest examples of algorithmic composition can be traced back to the 18th century with the creation of musical dice games by Wolfgang Amadeus Mozart and Johann Philipp Kernberger. These games involved rolling dice to determine musical elements such as melody, harmony, and rhythm, showcasing the potential for randomness and algorithmic processes in music creation. In the 20th century, composers such as Iannis Xenakis and Karlheinz Stockhausen embraced algorithmic composition as a means of exploring complex and avant-garde musical structures. Xenakis, a pioneer in the field, developed stochastic music systems that used probability and statistical distributions to generate musical sequences. Stockhausen, on the other hand, utilized serialism and mathematical algorithms to create intricate compositions that challenged traditional notions of music. Today, algorithmic composition continues to evolve with the advancements in technology, including artificial intelligence and machine learning. These tools enable composers to create music that is informed by data, patterns, and algorithms, leading to innovative and experimental works that blur the lines between human creativity and computational processes. Algorithmic composition has found a wide range of applications in the field of music, offering new possibilities for composers and musicians to explore innovative ways of creating and experiencing music. One of the key applications of algorithmic composition is the generation of complex and intricate musical patterns that would be challenging to create manually. Algorithms can be used to generate melodies, harmonies, rhythms, and textures that push the boundaries of traditional music composition, leading to unique and unconventional musical pieces. Another important application of algorithmic composition is in the creation of generative music systems. These systems use algorithms to continuously generate new musical material in real time, creating an ever-evolving musical experience for listeners. Generative music has been used in various contexts, including interactive installations, video games, and ambient music compositions. Algorithmic composition has also been employed in the field of sound design and electronic music production. By using algorithms to manipulate and process audio signals, composers can create complex soundscapes, textures, and effects that enhance the overall listening experience. This approach allows for a high level of control and precision in shaping the sonic characteristics of a piece of music. One interesting application of algorithmic composition is in the creation of music for film, television, and video games. Algorithms can be used to generate musical cues, themes, and background music that complement the visual elements of a media project. This approach allows composers to quickly generate music that fits the mood and atmosphere of a scene, saving time and resources in the production process. Algorithmic composition has also been used in collaborative music-making projects, where multiple composers and musicians contribute to a piece of music using algorithmic tools. These projects often involve the use of networked systems that allow for real-time collaboration and improvisation, leading to dynamic and interactive musical performances. Overall, the applications of algorithmic composition in music are vast and diverse, offering new avenues for creativity, experimentation, and exploration in the world of music production. Algorithmic composition, while offering exciting possibilities, also presents several challenges and limitations that composers and musicians must navigate. One of the main challenges is the balance between human creativity and algorithmic control. While algorithms can generate complex and novel musical material, there is a risk of losing the emotional depth and expressiveness that comes from human intuition and interpretation. Composers must find ways to infuse their personal touch and artistic vision into algorithmically generated music to ensure a meaningful and engaging listening experience. Another challenge is the potential for algorithmic bias and predictability. Algorithms rely on predefined rules and patterns, which can lead to repetitive or formulaic compositions if not carefully managed. Composers need to constantly refine and update their algorithms to avoid falling into creative stagnation and predictability. Additionally, the technical complexity of algorithmic composition tools can be a barrier for some musicians. Not all composers have the programming skills or technical knowledge required to effectively use algorithmic software, limiting access to this innovative approach to music creation. Despite these challenges, algorithmic composition continues to push the boundaries of traditional music composition and offers new avenues for creativity and experimentation in the digital age. The future of music technology holds exciting possibilities that promise to reshape the way music is created, produced, and experienced. One of the key trends in music technology is the continued advancement of artificial intelligence, AI, and machine learning algorithms. AI-powered tools are being used to analyze music data, generate compositions, and even assist in live performances. For example, AI algorithms can analyze vast amounts of music data to identify trends, patterns, and similarities, helping musicians discover new sounds and styles. AI is also being used to create personalized music recommendations for listeners based on their preferences and listening habits. Another trend in music technology is the rise of virtual and augmented reality, VR/AR, experiences in music production and performance. VR/AR technologies allow musicians and audiences to immerse themselves in interactive and immersive musical environments. Musicians can use VR/AR tools to create 3D soundscapes, visualizations, and interactive performances that blur the lines between the physical and digital worlds. These technologies offer new ways for musicians to connect with their audiences and create unforgettable live experiences. The integration of blockchain technology in the music industry is another trend that is gaining momentum. Blockchain technology enables transparent and secure transactions for music rights management, royalty payments, and content distribution. By using blockchain, musicians can ensure fair compensation for their work, protect their intellectual property rights, and streamline the music licensing process. Additionally, the rise of spatial audio technology is transforming the way music is mixed and consumed. Spatial audio techniques create a three-dimensional listening experience, allowing listeners to feel immersed in the music and perceive sound from different directions. This technology is revolutionizing the way music is produced, offering new creative possibilities for artists and enhancing the overall listening experience for audiences. As music technology continues to evolve, we can expect to see even more innovative developments that push the boundaries of creativity and redefine the future of music. During the Q&A session, audience members had the opportunity to engage with the speaker and delve deeper into the topics discussed. One interesting question raised was about the potential ethical implications of using AI in music composition. The speaker highlighted the importance of considering issues such as copyright, ownership, and the role of human creativity in the creative process. Another audience member inquired about the impact of virtual reality on live music performances. The speaker explained how VR technology is revolutionizing the concert experience by offering immersive and interactive elements that enhance audience engagement. A thought-provoking question was posed regarding the future of music distribution in the age of streaming services and digital platforms. The speaker discussed the challenges and opportunities presented by these changes, emphasizing the need for artists to adapt to new business models and technologies. One audience member asked about the role of algorithmic composition in preserving cultural diversity in music. The speaker highlighted how algorithms can be used to explore and celebrate diverse musical traditions, fostering cross-cultural collaborations and creative exchanges. Overall, the Q&A session provided a platform for stimulating discussions and insights into the evolving landscape of music technology.